When we come back, we travel to Pennsylvania, where student scientists are discovering how human activities impact freshwater ecosystems. Welcome back to Awesome Planet. I'm Philippe Cousteau. The Schuylkill River runs from the rural farmlands of Pennsylvania straight into one of the biggest cities in the country. Because of this wide variety of terrain, it's critical to monitor the human impacts on this important river system from top to bottom. Water is a fundamental necessity for life and is arguably the world's most precious resource. But while nearly 3/4 of our blue planet is covered by oceans, only about 1% of the world's water is fresh water that is accessible for human consumption. In eastern Pennsylvania, a yearly summer program called Schuylkill Acts and Impacts aims to teach local high school kids about freshwater ecosystems. Over the course of a week, these students will follow the Schuylkill River from its origins near the Appalachian Mountains to its intersection with the Delaware River in Philadelphia. Both the Schuylkill and the Delaware provide the drinking water for Philly's 1.5 million residents. So by studying the river, they'll gain a better understanding of just how critical freshwater ecosystems are in our modern society.
So a lot of people can just look at their tap and think, okay, well, this is where my drinking water comes from. They need to understand that drinking water actually comes from waterways exactly like the one that you're looking at here.
As they follow the river, the students conduct scientific tests to assess the health of the ecosystem.
What we're going to be doing today is we're going to be testing the chemistry of this stream here. If you guys want to get into your groups and grab your bags.
The students test the water for several different factors, including temperature, pH, and dissolved oxygen content.
Over here, we're doing the Winkler method for dissolved oxygen test. That'll tell exactly how much oxygen is dissolved in the liquid. 7.9 parts per million is the dissolved oxygen level. A number 7 and up means that the fish can breathe easy. Anything with gills is breathing free. That's good.
The students also collect samples of life in the water.
Right now, the kids are flipping over rocks, trying to find what little insects they're finding in the stream, and then they're going to take what they find and gauge it on the water quality index.
They primarily focus on cataloging the different types of macroinvertebrates, which includes crayfish, stoneflies, and water penny beetles. These creatures spend a significant portion of their lives in the river, so they provide a good assessment of the overall health of the ecosystem.
They're separating the things that they collect up into petri dishes and identifying them as far as whether they are species that are tolerant to levels of pollution or less than perfect water quality. Those are mayflies. Mayflies are a sensitive species of macroinvertebrate. So if you find those, it means that the water quality is going to be pretty good because they can only survive in really healthy waters.
A few days later, the students arrive in Philadelphia to perform their final set of tests.
Right now, I'm doing a dissolved oxygen test. I collected a sample from the river here. Throughout our test, the dissolved oxygen has actually gotten lower, which is not good. So here it was about 3.4 when it should really be between 6 and 10.
The students enter all of their data into a special app that tracks the results and stores the information. When they're done, they'll compare their findings to the other parts of the river and draw their own conclusions about how human activity is impacting this freshwater system.
It's really important for students to get a basis understanding of things and apply it in the real-world settings that helps them to understand the world around them.
I've always been interested in environmental science. Seeing it in the field made it a lot more real, and I was able actually to connect it and understand how it works.
There's a whole background to rivers and streams that people don't know. After this week, I'm definitely not looking at rivers and streams in the same way.